Good morning, dear students. As a part of continuous improvement, we have been dealing with case studies in our course engineering materials. And today we have taken an excellent material or excellent component of any system, that is a bearing. And I have taken a small case study which is done by EA Technology UK. Let me introduce the company. So EA Technologies' mission is to promote the development of resilient and accessible low-cost energy networks globally, accelerating the transition to energy decarbonization. So EA Technology is a specialist in asset management solutions for owners and operations of electrical assets. So headquartered in UK, our operations and customers are global with 4 regional offices around the world. So we are originated in 1966. So very old company that is pioneer in production of all the mechanical elements for windmill in special as a groundbreaking research and development organization serving the electrical industry. So this is a small introduction about this EA technology that is headquartered in UK. And let us go into the topic of turbine bearing failure case study. So before getting into the topic, let me quickly recap what is ball bearing, which we have studied in materials. So ball bearings are the mechanical components used to reduce friction between moving parts. They consist of series of small metal balls held within a circular raceway, allowing for smooth and efficient rotation or linear movement. So you have seen in your bicycle or bike, whatever you have. So you have a chain drive to drive the cycle. So at the end or in the beginning and the end, there will be a ball bearing located to withstand the load or transition of the load very easily. So the main purpose of ball bearing is to facilitate the movement of rotating or sliding parts while minimizing friction and wear. The balls inside the bearing roll or slide between the inside and outer raceways, reducing the contact area and allowing for smooth operation. So the design enables the bearing to handle both radial to the shaft and axial to the loads. So ball bearings are common, come in various designs and size to accommodate different applications and load capabilities. Deep groove ball bearings, these are the most widely used ball bearings featuring deep raceways, grooves that enables them to support both radial and axial loads. And we have angular contact ball bearings, thrust ball bearings, self-aligning ball bearings. So ball bearings are used in wide range of industries and applications including automotive, aerospace, industry machinery, robotics. They are a crucial component in various rotating equipment such as motors, pumps, fans, conveyor systems, where smooth and efficient motion is required. So it is worth nothing that ball bearings require proper lubrication to minimize friction and prevent premature wear. So this is common in ball bearings. The type and amount of lubrication depend on factors such as operating speed, load, and environmental conditions. Regular maintenance and periodic replacement of bearings are essential for ensuring optical performance and longevity. So that is what all about ball bearings. So in this case study, we would look into that bearing which is mounted in the turbine. So the analytical facilities available in the company is like these are all the things which is switch gear, transforms, tap changers. They analyze this moisture, acidity, breakdown voltage, everything, and they have optical microscopy to check the microstructure of all the things. So we have something called a scanning electron microscope, and we have something called as X-ray diffraction EDAX analysis. Mechanical testing, they have UTM, ultimate tensile strength, torsion testing to check the torsion, wicker hardness is to check the wicker's hardness of the material, surface roughness assessment is also available. So the asset is blade bearings in service for 10 years, protective coverings often unknown period, 4-point contact ball bearing system, induction hardened raceway, leave a soft spot, maintenance period every 6 months, actual maintenance is unknown. So the issue in this ball bearing pitch, there are multiple pitch in the errors across one side. So when we dismantle the bigger turbine, which is rotating air wind turbine, usually, which is rotating to produce electricity, they have a multiple pitch errors according to across one side, and there is a vibration of turbines. So whenever turbine starts to rotate to produce electricity, there is a feeling of vibration that is come across the blades. Seizing of two of the blades on one turbine. So there may be a possibility of seizing across the side. So this is very dangerous issue, or catastrophic failure may happen when it is left unattended. So the engineers they go along the way to dismantle and inspect the things. So we have to check. There is a checklist for this inspection. We have general external condition of the ball bearing, gasket assessment and removal, water ingress assessment, filler plug removal, ball bearing removal and conditioning, sectioning, raceway and cage assessment, grease assessment. That is, in the grease assessment, we have to check the general condition of the grease, elemental analysis. Both should be done. So this is the a glimpse of ball bearing condition, which is taken from the turbine bearing. So you could see there is some where the point of contact is there. There is some damage to the ball. So they are sectioning inner raceways and outer raceways, and then seeing what is happening in the turbine ball bearing, and the cage running surface will also have some scoring marks. So this is the cage condition, and we have erosion of materials. Like there is a material which is got eroded due to the continuous running of the ball bearing and without any lubrication. This is the condition that is going to happen. Under dismantling and inspection in this part indentation, material debris from cage or running surface. Some of the materials has been eroded, and spalling of the raceway and raceway breakup. This is what happens at the final thing where it creates noise and vibrations overall. So raceway degradation is one of the most major defect that is going to happen when there is no lubrication. Rolling contact fatigue is like whenever the ball bearing starts rotating continuously, and there may be wear that makes material indentations. This is due to lack of poor lubrication and sliding motion of ball bearings. So ball bearing has to roll like our earth. It has to roll, revolve around itself on an axis. It should not slide. Sliding may cause scoring marks in the cageway. And raceway degradation like low level vibration corrosion, false brinelling, so caused by micro movements under cyclic vibration. No significant wear or corrosion present right now in this inspection. So grease assessment is like you have to see whether it is dark, fluid, slightly thickened, suggested aging, some but not significant levels of material debris is there in the grease. So elemental analysis, we have to check whether the iron is present or not. That is done by this X-ray diffraction method. So summary of this case study is like good external and gasket condition and evidence of water ingress and rusting is there, weather protection not in place. So this needs to be addressed. And reasonable grease conditions, small amount of metal particulate, suggest grease has been changes recently. Cage and running edge wear, severe scoring and material loss caused by sliding friction and material debris, inadequate lubrication and radical clearance. So severe raceway degradations and breakup, indentation damage caused by the material debris or inadequate lubrication. No significant degradation around soft spot region O. 0 indicating failure was not due to the surface hardening or installation process. So evidence of false beneling, bearing vibrations has occurred could be the secondary due to spalling and raceway breakup. So the root cause is finally found at poor and inadequate lubrication or inadequate maintenance policies there. So this is what the findings of this case study. Finally, we have to do all these things, implications like installation practices, maintenance practices, condition assessment, monitoring. So nowadays, all the machines are monitored through condition monitoring. Like there is a continuous system which takes the health of the machine or the any parts that is running or rolling or whatever it may be, and it informs the operator that there is a wear or there is a problem or there is a noise or there is a some other mishappenings in the system that is monitored at 24 bar 7 nowadays. So consideration is like maintenance, grease sample, metallic particulate analysis, permanent online monitoring is required, and vibration detection, torque lubrication quality, and the temperature detection, automatic greasing systems. These are all the considerations that has to be made to avoid such failure. So I hope we will quickly summarize all these things. We have taken a company called EA Technology where the ball bearings are manufactured for windmills, and there is a problem in turbine which is used for generation of electricity. So in the turbine, we have a lot of defects with the ball bearings due to improper lubrication. We have seen the pictures, and finally we have concluded that these are the happenings due to a lot of things which is not followed properly, and suggestions are given in the last part, like you have to go for metallic particulate analysis and permanent online monitoring, like automatic greasing systems. So this will help the smooth functioning of bearing, and it will again improve the efficiency of electricity generation. I hope everyone understood this particular case study very clearly. Likewise, you can also analyze, so many mechatronic systems are available in the worldwide. So you can analyze the same, and you can study through case studies. So studying through case studies will give you a lot of insights, like understanding of the basic concepts, and it is very easy to troubleshoot any problem that is coming in the near future. So that is the purpose of doing this case study, and it is all done for you to train your mind to think. So with this, I conclude this case study presentation. Thank you. Myself, I am Sathish Kumar, AP SNSCE.